Hi everyone, and welcome to Mods 9.1 to 9.6. We're going to talk about sleep patterns and theories around sleep. Here are your learning objectives, and here is your vocab. So let's start with talking about the biology of sleep. So we have a circadian rhythm that is our body's internal clock. And this synchronizes, and I'm going to get into this a little bit more why, but it synchronizes with the 24-hour cycle of day and night. It can be altered and is altered by age and experience. So this image here just kind of shows you how we go through this and how our biological clock is set up for this. So for example, in the morning, our blood pressure rises, our melatonin that helps us fall asleep stops being secreted, and then as we go through the day, right, and then melatonin starts to be secreted at 9 p.m. at night. Now, actually, in people who are teenage age, about early 20s as well, the melatonin doesn't actually start being produced until a little bit later in the day, not too much later. So the stages of sleep we're going to go through. But first, what is sleep? So we consider that to be defined as periodic natural loss, I know it sounds weird, natural loss of consciousness distinct from just being unconscious, resulting from let's say a coma or being under anesthesia or being passed out, right? You are in sleep. It is a certain specific state of being unconscious. And you go through these sleep stages that we're going to explain. Every 90 minutes, you go through a whole cycle, okay? So you start over here being awake, right? And then non-REM 1 is where you start to fall asleep, okay? So you're not completely you might realize in this point that you're falling asleep. If you're kind of leaning on your desk falling asleep and you kind of wake yourself up, you are not in a deep, restful sleep right here, okay? This is falling asleep. Non-REM 2, you are a little bit further into sleep, but non-REM 3 is the deepest stage of sleep. And this is important for a lot of things we're going to talk about in a second. So this is considered deep sleep. You should know that non-REM 3 is deep sleep, and it's especially important for things like physical growth. After non-REM 3, you will go up to what is REM. Now look at the REM EEG pattern, the brain waves, versus being awake, right? They're much more similar to here, right, than they are to this, non-REM 2 or non-REM 3. So the brain kind of mimics being awake in many ways during REM. So this is what it looks like in a typical night's sleep of a young adult. So you start off awake. You do not go to REM, even though that's a lighter sleep. These are ordered and by levels of alertness. So this is most alert, less, the least alert, okay? So you start off awake, you go to non-REM 1 very briefly, right? You go to non-REM 2 for a little bit, and then see how long you stay in non-REM 3. That is that very important deep sleep that is important for growth and a lot of other things. Then after a period of time, right, this is a 90-minute cycle. So the cycle ends with REM. And you are in REM, and you should know this, for about 10 minutes, about. I know sometimes it might feel like you're in there for hours if you have a dream, because REM is where you dream. But you are not in REM for hours. So REM, by the way, REM, means rapid eye movement. These are all non-REM. When you are in REM sleep, it's also called paradoxal sleep. And the reason is because your muscles are relaxed. They're kind of paralyzed, actually, in a sense. but your brain is active. So it's actually like a protective thing that your brain is active and it's going through these dreams, and you do dream in every you dream every night in every REM. But your body is paralyzed so that your brain wouldn't carry out those things. Non-REM sleep just means non-rapid eye movement, and it's all of these other ones. All right, so there are also experiences such as hallucinations, and those are false sensory experiences, like seeing something in the absence of actually there being anything there. And those actually can happen with severe sleep deprivation, because in severe sleep deprivation, you're kind of stuck. You're not fully alert and awake. You're more like here. So that's when you can start to have those things, even though you're not fully in REM sleep. You can also have hypnagogic sensations, which is like that feeling of floating or falling. I personally get the falling one a lot, and that would happen more around non-REM 1. So again, in REM sleep, your body is paralyzed. So some people experience something called sleep paralysis, and that's when your body lingers in REM even after you are awake. And so people generally, not everyone, but people generally feel this is very unsettling, and they describe kind of like very disturbing like experience. It feels like something's kind of pressing on your chest. And you might get that too if you were in surgery and your body was paralyzed. It's just the feeling that you are numb. You can't control the rest of your body. And it's just like a moment. Sleep paralysis doesn't linger for a really long time or like an hour or anything. And it doesn't happen to everyone. But it is a thing that can happen. All right. So there's something called suprachiasmatic nucleus. Suprachiasmatic nucleus, or SCN, which is a lot easier to say. And it's a pair of clusters in the hypothalamus. So remember, the hypothalamus is the 5F. So it regulates, it is in control of our hormones, right? So it regulates the pineal gland to adjust melatonin production. So it's telling this gland when it is time to start to get sleepy. That's what you need to know. This nucleus, this SCN, tells the body when to release melatonin. Okay, so it affects our feelings of sleepiness. So what affects the SCN? So that is affected by light. Okay, so remember when I was talking about the circadian rhythm and how we kind of follow the daylight and nighttime 24-hour cycle? That is related to this. So this gets that message through light, through our body experiencing sunlight. However, in this day and age, we now have artificial light. I'm using artificial light right now. It is completely dark outside, and I'm using artificial light to engage, right? So my body is being delayed. The SCN is being delayed, and possibly yours right now if it's dark out, which it probably is. So that has altered us. So that's something that's not genetic, right? I mean, this is biological. This is in us that tells us it's time to go to sleep. However, we have altered biology with the light bulb, because now we can experience bright light on us, and that can affect our melatonin secretion and affect our ability to sleep well at night. Again, different ages need different amounts and types of sleep. Babies and young children need much more sleep, anywhere 12, 14 hours of sleep when you are very little. Teenagers need more like 10 hours of sleep, possibly up to 12 hours of sleep. And adults need less sleep. Now, some adults need slightly more sleep than others. So everyone is a little bit different. It's not an exact number for everyone. But sleep patterns. So if you like to be awake and then take like an afternoon nap ideally, or if you're someone who likes to just go to bed early, those are genetically influenced. There's a genetic factor to that. So maybe you're a nap family, maybe you're not. And it's also culturally influenced when we should sleep. Some cultures have an afternoon nap built into their day. Ours does not. Americans, we sleep less than Americans did 100 years ago. And again, think of all the reasons why that is in our culture. So what is the purpose of sleep? So first of all, it protects us. It protects us from predators. So it was an evolutionary thing that if we slept at night, we could stay hidden and protected. It also helps us recuperate. So it literally restores and repairs our brain tissue. So again, cannot emphasize enough that sleep isn't doing nothing. Sleep is physically repairing our brains while we sleep. And that would generally happen during that deeper sleep. It also restores our memories of the day. And this you should write down. The restoring of our memories, that seems to be linked to REM. If you don't get a lot of REM sleep, you are not, it's going to impair your memory. Okay? But in order to get to REM, your body has to successfully go through all these cycles. And one thing I should point out while I'm back here at this, notice how REM starts off as really small and it gets bigger as the night goes on. The more you sleep, the longer you are in REM. And guess what? That is good for your memory. It also helps us be more creative. People are able to be better problem solvers when they've had those 4 to 6 sleep cycles. So it's the whole cycle from the deep sleep to REM. And it also supports physical growth. As I said, that would occur during non-REM 3, that deep sleep. Okay, so our takeaways. Remember that sleep patterns, they are socioculturally influenced. They are biologically influenced, our sleep patterns. They are influenced by our circadian rhythm, our SCN. There's all these factors that go into when we sleep and why. Make sure that you know the 4 stages of sleep and what each means from non-REM 1, 2, 3, and REM. Make sure you know why we have REM sleep, and then all of the theories of why we sleep. All right, so that wraps up 9.1 to 9.6, and I will see you all in class. Thanks.